Wasting our time, we'll move to next technical session, which is on quaternary paleoclimatic and paleoenvironment changes and geoarchaeology. So participants will move to our next session, quaternary paleoclimatic, paleoenvironmental changes and geoarchaeology. I like to invite chairpersons, Professor L.S. Chamial sir, Professor Vishwas Kade sir, and Shri Vishal Sakre sir to come on the dais and chair the session. Professor Chamial sir, he is eminent quaternary geologist. His work is highly referred and cited all over the world. Professor Vishwas Kade is a geographer by profession, and he is ex-HOD of Department of Geography, Savitri Bai Phule Pune University. And Mr. Vishal Sakre is SHO, GSI Nagpur, and his specialization is geothermal energy. So it is great to have all three of us with us. Now I like to invite Professor L.S. Chamial sir to give a keynote address.
A very good morning to all of you. At the outset, I would like to thank the organizers, particularly Dr. Samia, for the invite and also for giving me an opportunity to be one of the chairs for this session. So I believe that, since there are two key keynote addresses in this session, and some 4 or 5 papers are to be presented, and I believe that all of them are there. So without taking too much of time, I think start with my presentation first. I'll take that advantage of being the chairperson. It's there already, okay. So the topic of my talk is basically, I'm going to talk about the fluvial records from Gujarat alluvial plains, where I have been working for almost 3 decades. So I'll be only giving you a gist of the work that we have done at Baroda. And the work is not solely mine. This work that I'm going to present involves many of my students and colleagues, and therefore the credit should go to my students as well for the overview that I'm going to give you about the fluvial records from late quaternary time period, and how actually these records have been used to address climatic changes in the near past. So as you know that, Gujarat region, which is basically the southern margin of the Thar Desert, has presently 3 major climatic zones. You have arid climate just to the south of the Thar Desert, and then major part of it lies within the semi-arid climatic zone of Gujarat, wherein we have a very extensive fluvial system. And then in the southern part, the climate is subhumid, and the 2 major rivers, Tapti and Narmada, flow within the subhumid region. These rivers have actually a lot to tell us. For the last, I would say that for the last about 100,000 years, we have an exposed record of sediments in that region. And basically, I call it basically southern Thar Desert margin, and southern Thar Desert, any desert margin is very sensitive to climatic variability. This is a hard fact. And then, in this part of semi-arid regions, basically southern part of the Thar Desert, we have a very strong fluvial system, which actually either meet the Gulf of Cambay, or some of them flow towards the Run of Kutch, mainly the little run of Kutch. And this system has been very dynamic actually, and it's the existing system that I'm showing you here, but the fluvial record that I'll be showing you in the subsequent slides, you will see actually those are not the product of these rivers. So these rivers have arisen in the very late Quaternary time, maybe less than 20,000 years or so. But the fluvial record dates back to 125,000 years. Therefore, we also have to understand the sea levels here. Professor Rajiv Nigam and many others have talked a lot about the sea levels yesterday in this part of the continent also, where you see that, very briefly, 125,000 years, the sea level in this part of Gujarat was about 7 to 8 meters high. And our Saurashtra Peninsula as well as the Kutch, they were not connected to the mainland Gujarat. They were occurring as an island. And then the sea level went down to about 140 or 50 meters during the last glacial maximum, exposing a major part of the shelf area. And the rivers extended their courses and were even, today we have continental terraces at a depth of about 100 meters even in that region. So that, that is a solid evidence to say that the sea level went down by 140 or so meters in this part. Then again it rose between 6 to 2 kilo years, about 1 to 3 meters. And then again these islands, Saurashtra and Kutch, they were again rather disconnected from the mainland Gujarat. And they got connected only during last 2,000 years. That was important because when we try to address the evolution of the alluvial plains in this part, we need that there are three dominant factors, controls rather. One is the climate, the other sea levels, and third is, of course, there is significant role of tectonics also. So briefly, if one wants to know about the very salient features of these rivers, you all know that these rivers are all monsoon fed and they are highly incised in the alluvial reach. When it comes to incision, the incision of the order of incision that we see in Gujarat alluvial rivers, you don't find it anywhere in the world. Such a vast Indo-Gangetic plain we have, but you will find the incision of the order of 8 to 10 meters only. Whereas here you have incision up to 40, 50 meters. And these are basically archives since late Pleistocene. They have estuarine river mouths and are located in semi-arid belt that overlies the Cambay Basin. And sediments exposures are 20 to 40 meters thick. And they have the mid-late Holocene sediments actually occupy the incised valleys. So these are very I would say that some of the highlights of these rivers basically, not in greater details, but I would like to just show you some field pictures from the three major rivers. All three of, two of them are from semi-arid regions and one from subhumid. This is one very important river which has been studied extensively, not only by our group, but many others from abroad also. And what you see in these pictures here, we have sediment record for three major depositional environments. We have a marine clay, which is around was deposited around 125,000 years. That is the time when the sea level was high. And then we have a extensive fluvial record which extends right up to 11,000 years. These fluvial sediments, they are mainly made up of fine sand, silts, clays, and gravels, and also intercalated soils are there, some failure soils, 2 to 3 failure soils also we have. We also have some kind of deformational features which is not clear in this photograph, unfortunately. But then what I am trying to say that we have a basal marine clay which is overlain by fluvial sediments which date back to 125,000 years to 11,000 years. And then we have a capping of aeolian sediments dating back to, at this particular location, dating back to around 11,000 years. So if we, this is for students' purpose, basically I have put this slide. Basically, we need to prepare a physical stratigraphy of the exposed sediments. So incision here is around 36 to 38 meters. This is a place called Raika, and this has been considered as a type section for quaternary continental sequences, even visited by the INQUA committee. So here what you see, the same sequence, like I said that you have this marine clay overlain by gravels which alternate with fine sand shells sequences. And we do have 1 red soil here and 2 brown soils, brown failure soils intercalated within the fluvial sequences and overlain by aeolian sands. So this is one very good section for anybody who works on continental quaternary sequences to visit from the point of view of the sediment history or sediment record for last 125,000 years. Similarly, if what we did actually, I am just giving you just a summary of the work done, because these sections all along Narmada as well as Mahi or Sabarmati were logged and at various places measured. These are all measured logs, and then in summary, you will see that at all places basically you have a marine clay which is overlain by fluvial sediments and capped by aeolian sequences. And the upper part correlates with MIS3, and the textural and sedimentological characteristics, they point to the deposition by an ephemeral system, fluvial system. This is the summary of Mahi. And then you come to Sabarmati. This is one field photograph of a meander within Sabarmati, a place called Mahudi. And along this, this section is around 40 meters or so, and which was basically considered as type section for reconstruction of stratigraphy of Sabarmati. And then other sections I am not just skipping because of time constraints, but then similar way, like in case of Mahi, we tried to reconstruct the physical stratigraphy of the sediment sequences along Sabarmati. And what we see that there is a reasonable correlation between the sediment sequences in Mahi and Sabarmati, and both flow within semi-arid climatic zones, and both arise from Aravallis and pass through the vast alluvial plains of Gujarat and meet the Gulf of. Now coming to this river, the Narmada, which is a bit bigger river, larger river than the other two, which has a longer catchment of about 1,000 kilometers. What we see in case of this Narmada, that we have basically 2 sediment facies. One coarser ones, they are deposited in an alluvial fan environment, and the other finer ones, we call they are deposited in alluvial plain environment, mainly overbank deposits. So, but then the sequences are extensively very thick, means about 40 to 50 meters. This is one locality within Narmada Basin, which was actually used for understanding sedimentary facies and depositional environments within the Narmada Valley. And then, when we tried to reconstruct the physical stratigraphy of the sequences within Narmada River, what we find a marine clay at the base, as in case of the earlier two rivers. But when it comes to sediment sequences, we have two sediment facies within Narmada. The lower one is alluvial fan facies, followed by the alluvial plain facies. And because of the very long catchment for the sediments, within Narmada, these sediments are, the clasts are rounded, and the alluvial plain sediments have large-scale sedimentary bed forms, which actually point to the catchment further east, located in humid climate, basically. So we do have paleosoils within Narmada sequences also, which actually help us in understanding paleoclimatic changes. If you put all three together, you will find some regional correlativity. You will find that by and large, the depositional environments have been similar in all the three rivers, and only thing that there could be some change in sedimentary facies, etc. Otherwise, by and large, there is no change in depositional environment, and there is an excellent correlativity if you put all three together. Then, as I said, that another important aspect in case of this particular area, as it forms the part of southern part of the Thar desert margin, so the Aeolian sequences become very significant. And from that point of view, when we try to understand these Aeolian sequences, we find that Aeolian activity was extended right up to the Narmada, and it existed till 21,000 years. Similarly, in case of Mahi, as I showed you earlier, around 11,000, up to 11,000 years or so, the area was a desert only and known as Paleothar actually. But when you come to Sabarmati area, the Aeolian activity continued till 5,000 years. So how it happened, basically if you look at this particular diagram, you will find that during 20 to 12K, that's the time of LGM, the entire area, entire southern Thar margin, there was active dune formation. I mean, Aeolian activity was very extensive during 20 to 12,000, and 12 to 8,000, there was no dune building. There was no Aeolian activity because of the change in climate, and all dunes were basically stabilized. And then again, between 8,000 to 5,000, the Aeolian activity was restricted in the northern part. The southern part did not have any Aeolian activity during 8 to 5,000 because you do not have any dunal activity beyond 5,000, and that is restricted to the area of Ahmedabad only. And then, today everything is stabilized. There is no Aeolian activity as regards Gujarat alluvial plain or southern Thar desert margin. But this has actually helped us in understanding how exactly the southern desert margin has shifted towards the active Thar desert now. Based on that chronological data, the Aeolian activity was up around 20,000 years. In the Narmada basin, around up to 10,000 years. In the further north, in the Mahi basin, and then around 5,000 in the Sabarmati basin. And then today it is, last 1,000 years, it is the active Thar desert basically. So that study of Aeolian sequences actually helped us as to how this Thar desert margin got shifted from what was known as Paleothar, right from Narmada, where we had subhumid climate, to the present-day Thar. So these Aeolian sequences helped us to understand this shifting of Thar desert margin, and also helped us in understanding the paleoclimatic changes. And it also helped us in understanding monsoon conditions. I will not take much time. because this is mainly based on the sediment sequences, the composite log that was prepared for the rivers, for semi-arid river basins of Gujarat. Based on the sediment record, what we find that we, during the, this clay, basal clay that I showed in one of the slides, the monsoon was enhanced and there was a braided channel deposition where the monsoon was weak. Then you have floodplain aggradation and bedded concrete formation. The monsoon got enhanced again with seasonality. Likewise, based on the sediment characteristics, we could actually infer the geomorphic processes that were operative and the inferred monsoon based on the geomorphic process and sediment record. It means what I am trying to say that these sediment sequences have actually helped us to understand how geomorphic processes have operated in that region and how the monsoon has varied. And ultimately, it helped us as to how, the geomorphic evolution of that particular region, what we see today, has actually developed, how the landscape has developed, in other words. So that way this has helped. Similarly, during early Holocene also, please tell me when the time is there. Time is there still? Okay. So during early Holocene, that was the part mainly restricted to Pleistocene, late Pleistocene. Now coming to Holocene time, what we see in the early Holocene time, there was actually, termination of gravel deposition and braided river environment right up to 9.2 in Mahi and up to 6,000 years in Narmada, and there was subsequent incision in both the basins. These observations helped us to understand the variation in the monsoon during the early Holocene, like during in the Mahi during 9.2 Ka, the monsoon was weak to enhance. Similarly, in Narmada it was around 6 Ka, weak to enhance, and subsequently it has enhanced all afterwards. So then that was the scenario during early Holocene. But you come to mid Holocene. Mid Holocene, we have an excellent record there, right from 3600 to 1700 years. So wherein this particular geomorphic surface, this is the sequence that we could study or log basically. So we have an extensive marine clay here, overlain by fluvial sands, and again marine clay. So it's a typical situation of an estuarine mouth of these rivers. And this is actually a marine terrace here. And it also helped us to understand the sea level changes during the mid Holocene time. But of course, here we have to decouple the roles of tectonics as well as climate in when we try to envisage or when we try to adjust the sea level changes. Likewise, from Narmada also we have records available up to 1200, 1300 years. So now we are actually able to reconstruct at century scale the changes in the paleo-monsoon or paleo-climate that the area has experienced. And when you try to put all these three, the inference that is drawn is basically for Mahi, Dadar and Narmada, there are some correlatability is there between these three river sequences during the mid to late Holocene. So what I am trying to tell you, if you try to timeline-wise climatic changes, if you try to envisage based on these exposed sediment records. So what we see that we can actually reconstruct paleoclimatic changes and also can understand geomorphic processes right from 125,000 years to last 2000 years based on these sequences only, wherein of course multi-proxy data has been also used or generated to address. So what we see, the changes in terms of climate, right from 125 it was humid, and it is very well represented by the floodplain fine sediments that I tried to show you at the base of these sequences. And then we have, 90 to 70, the climate was subhumid to humid. Floodplain, the geomorphic process involved was floodplain aggradation and bedded calcrete formation. Then 70 to 60, arid, 50 to 30, humid, 30 to 20, progressive arid. 20 was the peak aridity. That is the time of last glacial maximum. And then 20 to 10, there was progressive strengthening of southwest monsoon. 10 to 5, overall humid with arid interludes. That is the time when in-season was there and later valley fill was there. 5 to 3, there was progressive aridity, and last 2000 years there is no change in climate. So similar to present. So that's what is the inference drawn based on, exclusively based on these sediment records for the continental part of this particular area. And the highlights, as I have been telling, I think I need not to repeat this. There were, a fluvial regime indicating fluctuating hydrological conditions, 120 to 30, 120,000 years to 30,000 years. The systems change frequently from meandering to braided or braided to meandering, vice versa. But then there was a plain aggradation around 100,000 years. Then second phase was around 98 to 69,000 years. Then 49 to 30 kilo years. So these were the floodplain aggradation events. And then post 30K, the region witnessed a phase of regionally extensive aeolian activity, and followed by a high phase of precipitation and rise of sea level and tectonic uplift during early Holocene. Present day fluvial regime from these data appears to have developed, formed only during last 20,000 years. And in season, of course, rested is within these is 14 to 10 kilo years. And the formation of estuarine to valley fill terraces 5 to 3,000 years, and the channel responses to climate change can actually demarcate through a close examination of the river geometry and sediment deposit. That's the inference drawn. I think I have done with it, and thank you very much. There may be some more slides, but then I would like to end up here. I think I am well within time. Or?
Yes, you are well within time, sir.
Thank you
very
much.
Much, sir. The house is open for discussion, if any.
If there are any questions, I'll be very happy. Yeah.
An excellent presentation, sir. And many of these things probably did not have idea so much. But your dating of these so young Holocene and mid-Holocene sediments you are talking about, even up to 2000 years, how it is all through carbon dating or something new also?
Both, I think for the younger sequences it is AMS, carbon dating, radiocarbon, and of course we have used OSL also. For Pleistocene sequences, mainly OSL, and for Holocene sequences, we tried both, but the numbers that I have presented here are based on radiocarbon.
Radiocarbon. Thank you, sir.
Thank you so much, Professor L.S. Samuel, sir, for giving very nice deliberation on records of late quaternary climate. Hello. So, once again,
Thank you. Thanks to all of you, and thanks mainly to the organizers, as I mentioned earlier, my friends from Geology Department of Nagpur University and all others. I really enjoyed my 2-day stay here, and I thank all of you. Thank you very much.
Now I request Professor Vishwas S. Kale to give his keynote address on specially variable impacts of late quaternary climatic changes on the dynamics of the Deccan Traps river systems. So, Professor Vishwas S. Kale, please.
Speak on the response or the behavior of the rivers in the Deccan Trap river, Deccan Trap region, rivers that originate mainly in the Western Ghats zone. Now, when we talk about the late quaternary period, I mean, you are aware because of changes in the Earth's orbital parameter, the climate on the global scale as well as the regional scale has undergone different phases of changes. And in the low latitude particularly, where a lot of data have been generated in the last few decades, the glacial periods were usually associated with a drier climate, semi-arid conditions, and the aggradation in the river valleys. While the interglacial in general, they were associated with the degradation or incision. So this is a very generalized picture that has emerged from all the data available from the low latitude regions. And if you see the last up to 5 or 6 MIS stages, then there are phases of aggradation coinciding with LGM, then around the 4 and 5 transition, and slightly at the end of the MIS stage 6. And during the intervals in between, generally it was believed that these are the phases of aggradation, that is, the river is eroding its own deposits. Now I'm basically going to talk about the fluvial records from this part, and I have like to emphasize that rivers, particularly in our landscape, the river is the most sensitive element of the landscape. The river is the first to react to any change in the environmental condition. Whether it is climate, whether it is tectonics, whether it is base level or sea level, river is the first to respond. And therefore, observing, monitoring rivers, analyzing the behavior of the rivers today as well as in the past can provide you enormous amount of information about the changes in the environmental condition. And climate is one of the elements of the environmental conditions. And fluvial records have been used in order to reconstruct the catchment hydrology, the basin hydrology, but it is fraught with many problems. And we should be aware of this. Now this is because although the main river, the parent stream, the trunk stream, the axial stream is the most sensitive, but the drainage, if you are aware, the rivers have an hierarchical organization. And some parts of the basin, particularly the tributaries, they respond to the changes in the environmental condition in the catchment hydrology with some lags and leads, and there are differences in the response because there are many other factors which also play an important role. And we are also aware that the fluvial record is not complete. At times it is missing because during phases of degradation, some of these records are flushed out from the system. And many times the rivers shift, they migrate, they change their courses, so therefore the record becomes incomplete. And apart from climate, in every region, there are other factors that also play an important role. So as I mentioned, I'm going to talk about the Deccan Trap rivers originating in the Western Ghats. So this is roughly the area, the rivers that originate the Krishna and Godavari and their numerous tributaries. Now this is not because this is south of the Sonata zone and the Camber Rift region, so this is not the area of deposition, of a gradation. This is basically an erosional landscape. The process is a rocky landscape. But in spite of the typical nature of this landscape, the rivers have preserved the evidence of the past changes in the environmental conditions. And there are some rivers which are some areas shown with the help of stars where you have unusually thick, by this standard. I am not comparing them with the Narmada, Tapi and Mahi, the rivers that occupy the Sonata zone or the Rift zone. So this is basically a tectonically stable landscape, is generally believed, although many people disagree. Even in the coastal areas, you have very thick deposits, and not just the silt sandy deposits, but also indurated gravels, indurated sand layers. So induration and these kind of characteristics, they indicate the duration of the record is much longer. And even in the semi-arid parts, in the rivers which do not originate in the Western Ghats, they also have such deposits. And there are some areas which I consider as infilled basins. And so these are, when you consider the erosional landscape, these are very unusual. And thanks to Professor Rajguru from Deccan College, who was our supervisor, my supervisor, this is also an area where enormous amount of data and large number of radiometric dates have been generated. All these stars, they represent the localities from which we have radiocarbon dates, and the alluvial records have also yielded enormous amount of fossils as well as archaeological material, artifacts, and therefore the general pattern that has emerged, that I am trying to understand. And I am going to focus on these four aspects. That is, what is the length of the record that is preserved in the valleys of these two rivers and their tributaries? And why certain infilled basins are found in certain localities, and the available data also shows that there is asynchronicity in the behavior of the rivers. The Ghat rivers and their tributaries, they show a mismatch. And this area was also occupied during the mid-Holocene times by the Chalcolithic cultures, and their sudden disappearance is also a point that is generally believed to be associated with changes in the climate in that region. Now we have nearly 50 odd radiocarbon dates from this. Now when you just plotted their midpoints, ignoring the errors, you'll find that there is concentration along LGM. So for a long time, when we did not have other information, other methods of dating were applied, it was believed that the LGM was a phase of the major phase of aggradation in this particular part. So so I undertook this meta-analysis of all the radiocarbon dates and estimated the probabilities of occurrence during different time intervals. And we see that we don't see distinct clusters, which would be expected if the deposition was confined to certain periods, certain intervals. In fact, it indicates that the deposition has been going on for a pretty long time in this particular region. And we also know from other proxy record, whether it is marine or the continental records, that distinct changes in the rainfall pattern have occurred in the past, but that is not reflected in the alluvial records. Now there are these thick deposits which are occurring in certain areas and which have yielded Acheulean artifacts. All these pictures that I'm going to show is my collection. Okay, please, I'm not taken it from my other colleagues. So so these are Acheulean artifacts, and although they are occurring in the deposits, and all the radiocarbon dates are suggesting that these are all the sediments were deposited most likely during the LGM. They coincided with the LGM phase. But the occurrence of these Acheulean tools, they are telling us that these deposits are much older. And there are a large number of fossils. This is again my collection. And when we dated some of this, and we found that the length of the record is much longer. And the discovery of this volcanic ash in one of these rivers by one of my Guru Bhai, Dr. Ravi Korisetta, this is Professor Rajguru. This volcanic ash, thick layers are occurring within the alluvial deposit. So obviously, and we know that this is about 74,000 years old, so the alluvial records are definitely older than 75,000 years. So the length of the record has gone beyond the LGM. It has gone beyond stage 4 on the basis of the alluvial deposit. And one of the tusks that I found in the upper Krishna basin was dated by uranium thorium to 81,000 years. And this tool and the associated deposits were dated to about 200,000 years. So obviously, what was the earlier initial impression that all the major deposition took place during LGM, that has proved to be wrong. Okay. So now when we present this, and we have other type of records and some uranium thorium dates, the pointer is very weak. So this indicate that the deposit is almost more than 100,000 years old. And we have used other relative dating methods also, like the fluorine phosphate ratio, that tells us that the deposits are fairly old. And for example, this tusk which was found in Krishna, the fluorine phosphate ratio is 4.4. And this tusk which we found in the Bhima basin, it is the ratio is 5.8. So obviously it is much, much older, that is evident. Now the second point is about the thickness of the deposits. So they are all associated with, now these deposits, if you see, that upstream of that, you have these kind of gorges. And these gorges, which I have just now shown you, that is occurring somewhere here. And below this, you have these huge infilled basins. So obviously, the connection between the gorges, which are dominated by incision, indicates that climate cannot be the sole factor responsible for this aggradation. Because this kind of incision in bedrock of 70 to 80 meters cannot be induced only by increase in water. There has to be other factor like tectonics, which has played an important role. And the meta-analysis also shows that the deposition has been going on for a long period of time. And then another factor which I'm discussing about is this rivers in the rain shadow zone. So the rain shadow zone of the Western Ghat. Now some of the tributaries that are originating in the rain shadow zone, which I call it as the core dry zone, the tributaries have behaved differently. Now when you compare with this is the record from Lonar, and it shows during the early Holocene, the climate was better, and during the mid Holocene, the rainfall, the monsoon was weaker in this particular part. And we have also found the calc tufas, and the dating suggests that yes, the early Holocene was very wet in this particular region. But some of the rivers in the dry zone, which I call it the core dry zone, which is the rain shadow zone, were not behaving like the other rivers. Their response was very different. And what I believe that this zone has shifted or enlarged. So without a change in the monsoon condition, because this has shifted or has enlarged this area, the response of the rivers has been different. And why this zone exists? It is not because of climate, it is because of topography. It is because of the Western Ghat, which is a non-climatic factor. So as a result of this, there is differences in the response of the rivers. And the last aspect is about the agriculture-based the Deccan Chalcolithic culture. Now this is a map that I have prepared showing almost 800 sites that are occurring here. And these are in this rivers of our study area. And it is believed that these settlements were established between 4.5 to 2.8 Ka because of a major dry phase during the mid-Holocene period. And that is, you can see here that it's still weak. This is the arid phase, and after the end of this arid phase, there was a paper in the scientific reports which has suggested that the dryness was particularly responsible for increase in the agriculture settlement. So I would like to conclude on these particular 4 points that looking at all these records, the 4 main observations are that the fluvial sediments have a pretty long residence time, that we have deposits in this area which have recorded the fluvial history for more than 100,000 years definitely. And perhaps we have better dating methods, perhaps that record can be extended further. And the infilled valleys, they are associated with bedrock gorges, indicating that apart from climate, other geological factors have also played a role. So the deposits are not necessarily telling us about the climate. And the non-Ghat rivers, which originate in the semi-arid parts, they have behaved differently. So trying to interpret about monsoon on the basis of their fluvial record will not give you the correct picture because their behavior was different. And finally, it is believed that the Chalcolithic settlements, they declined after 3K. But when we look at the proxy record, paleoclimatic record, we find no indication of a sudden or a dramatic change in the climate. So that remains a mystery. And so the general conclusion is that the behaviors are very, very complex in a particular region. When you talk about the regional scale, the picture that emerges, if we try to generalize, it matches with the global records. But if we go into the details, you find there are enormous spatial variation or interbasin or even intra-basin variations in the behavior of the records. And the asynchronous behavior of the rivers within a region, within a climatic zone, within a geological zone. And please believe, you know that Deccan Trap region is a homogeneous region. There is no variation in lithology. So other than climate, non-climatic factors have also played a very important role. And the decline in why the Deccan Chalcolithic settlements declined is a mystery. People say it is because of climate, but at least from the proxies that are available, there is absolutely no indication of that. So unless there is some hydrological change that has occurred in the distribution of rainfall, annual distribution of rainfall, or something which cannot be assessed from the fluvial records, from the speleothem records, or from the lake records, the distribution of monsoon rainfall in a year, these are something that is very difficult to infer from continental record. So unless we are able to do that, we will not be able to solve the mystery. 18 minutes have passed. Thank you very much.
Thank you, sir. Now the session is open for discussion.
Yes, please. Yeah, yes.
Sir, myself Rakesh Bora. So your presentation is very attractive to me, I feel. But the question is not for regarding this presentation. The question is like different, sir.
Yes,
So as we are working in the offshore part, we are getting some Pleistocene and rivers, channels.
We are getting
sometimes-
Pleistocene?
Yeah, Pleistocene, some deposits. also.
Okay, okay.
We got some
Fluvial or
hydrocarbons.
marine?
Yeah, marine.
Marine.
So, but sediment must be from, we are
Okay,
probably
okay.
thinking that it is
Okay,
Krishna
okay.
or Godavari. But they are actually behaving differently, Godavari as well as Krishna, as our understanding.
Okay.
So, but we want to know some of the provenances,
Provenance.
particularly different rivers. Suppose
Okay.
Krishna, some of the tributaries may be coming from different parts, and Godavari also some difference. So, if possible, suppose in future, if some papers will come out like some heavy minerals on detailed
About the
analysis.
provenance.
Yeah, provenance.
वो बैठे हैं ना एक्सपर्ट आपके पास?
Yes.
वो बैठे हैं?
Yes, lots of reports are there.
No, no, no. He is an expert
Yeah,
on
yes,
that.
sir. So-
He will be able to.
This is my actually query.
Yeah, yeah. Yes. But you are talking about Northern Arabian Sea or Bay of Bengal?
No, Arabian Sea. Bay of Bengal.
Huh?
Bay of Bengal.
Bay of Bengal.
Yes, yes.
Okay. I mean, he will tell you more, but I am aware that there are so many publications.
Publications, sir.
Yeah, of the offshore records, and they have been able to, apart from provenance, how the input from the rivers has varied through time, that has been reconstructed. Yes. Yeah, there are publications.
Yes.
If you want, I know some of them,
Yes,
I
yes.
can share with them with you.
Okay.
Yes.
Sandeep Roy sir want to tell something.
Yeah, there. Sorry?
Mike.
Am I audible? Yeah.
Yeah.
You made a very interesting comment about the LGM, last glacial maxima,
Yes.
that it did not register in your working
Yes,
area.
it did not.
It did not register, or it did not. It was not operative. LGM was like not there in the area which we.
No, no. No, no, I
Then
didn't
what
say
was
that.
what was the comment like? I would love to
My
clear.
comment was in the initial stages when the only dates that were available were,
Mhm.
and when we plotted them, it showed that they all clustered around LGM. Okay.
So then LGM was operative.
Yeah, LGM was a
No, no,
phase of
it's
very
a- it's
weak
a
monsoon
statement on-
rainfall.
it's a
So
statement
everybody
on either
thought
way.
that it was a major phase of aggradation around LGM, and all the alluvial records that we have, they belong to LGM.
That's fine. Even that is also a takeaway because
Yeah.
the LGM matter actually did not operate fully throughout the globe, right? At some places in Antarctica, LGM actually was absent. Before that,
No, how can LGM be absent?
No, in some
LGM
parts.
was there.
No, no. In some
LGM
parts, in some
No, you
part-
are saying that the corresponding record was absent.
corresponding record. Suppose.
Yeah.
Let me explain. Suppose there is a deglaciation phase going on in Antarctica in many places.
Huh.
In Antarctica.
Yeah.
So in some places, the deglaciation has happened much before LGM, so it was ice free. Getting it? So LGM probably did not operate on those places. It's the same type of cases are there in Arctic. No.
See, LGM was there. There is no
That is a
dispute.
play of word. That is okay.
Excuse
But
me.
I wanted your view on the LGM at the area of yours. So you are saying that dates were there of LGM dates are clustered there
Earlier.
earlier. Okay.
Earlier, when only radiocarbon dates were available, and they are mostly on shells, there are a lot of problems with those dates.
So what are the OSL dates? What are the OSL dates of that area, or for that matter, cosmogenic radionuclide of that matter? Any
No, we
CRN
don't
dates?
have cosmogenic or nuclide. What I am saying, the occurrence of artifacts and the uranium, thorium dates of fossils or the cementing material, it has indicated that it can go beyond 100,000 years. The same record which we thought were only LGM, they are much older. That's what I'm trying to say.
So no comment on LGM in that sense.
No, no, during the LGM deposition has taken place.
Okay.
There is no doubt about it. But the entire sequence does not belong to LGM.
No, that's
That is-
understandable. That's understandable.
Yeah,
It's a
that's-
huge sequence. Okay, thank you.
Okay, I think, no, thank you, Professor Vishwas Kale, for an excellent talk. And let us give him a big hand. Yeah. Okay.
Thank you, Dr. Karni, sir. Now I like to invite Shri Vishal Sakre, who is presently working in GSI Central Region Nagpur. He is having specialization in geothermal work. So I like to invite him to say a few words on his work and experience for geothermal energy.
Very good afternoon all. आप सभी को मेरा नमस्कार. Actually, being the executive member in GGS, we have dropped my keynote address because there were a lot of keynote address and time was very short. But at the end of the this session before, our close friends from GGS and from GSI told me we want to hear a few words from you regarding geothermal. So at present, within that 5 minutes, I am not able to present the PPT, but I don't need the PPT. I can talk hours on geothermal, no issue. So here in this session, I will just talk 5 to 12 minutes, not much, because time is constant. So I will just want to tell you the overview of geothermal energy resources in India. This conference, we are mainly in this session, we are talking about the climate, paleoclimate and climate changes. So when you talk about the climate, so then you think for the green energy. Because climate is changing. Before also in nature, change is life. In nature, things are changing. But the rate of change of the earth system is in millions of years. But due to the urbanization, industrializations, we are giving more pollutions, and because of that, we are facing the recent climatic changes. Even in Nagpur recently, we are finding the climate has changed, shifted 1 month. In April, we got a lot of rains. Now in June, there was no rains. Yesterday only monsoon arrived. So climate is changing, so we have to change. If we don't change now, then things will be worse for the humankind. So here, in Italy, now it's a carbon neutral country. In Italy, before there was a lot of coal plants, but due to all this ozone effect and climate changes, they wanted to shift it to green energy. Now there is no thermal plants in Italy. In the same line, most of the countries of the whole world are trying to go to green energy. And due to this also, our Honorable Prime Minister of India, he has given the target by 2030. He wants India to be at least 50% energy resources should be from the green energy. So that is the big challenge for the policymakers, for everyone. Solar is already established, hydroelectric project is established, but they have their own constraints, limits. So now what else? Tidal energy is there, but still it is not that developed. So now policymaker thought of the geothermal. In 2013, Geological Survey of India started the geothermal investigation, restarted it. And since 2013, we are working in this field. Previously, of course, we have worked, but due to some issues, the division was closed. So last 1 decade, we have monitored all the hot springs available in India. So recently, total 381 hot springs has been geologically studied by Geological Survey of India. Basically, GSI is having the resources to do the survey for all these hot springs. So that's why we could able to reach each and every hot springs. We could able to put our manpower for the investigation, right from the collection of the water sample to the geophysical survey to the exploration. Exploration is also one of the important part because very costly, but GSI can do it. So we have did a lot of borels also. Then we have, based on this, I will tell you, recently we have published Geothermal Atlas of India in February 23. It is in public domain. So in that publication, we have included 381 hot springs of India with all details. And the last hot spring, Demchok hot spring 381st, is last but not the least because it's very special because that hot spring was never investigated, never monitored by anyone in this world because that hot spring is just at the border. One 10-meter nala is there. This part, that hot spring, that side is the China. So last year also we have visited that place. Last year it is in Leh Ladakh. So actually I am supervising all the geothermal projects across the India, so from Nagpur. So my team has reached there and they told me that there is one hot spring and you want to check it. I said, okay, let's go. So with lot of difficulties, they can reach that place, Demchok hot spring, with lot of security measures. It takes 2 days to reach that place. So that hot spring also now, one international publication is also we have given for the hot spring. So I just want to tell that GSI has the access to do the research, to do the work. So total 381 hot spring already we have studied so far. Now this is for the hot spring. What about the green energy? Because hot spring will not, so here what happened, when I had taken over the charge of geothermal division, so when I talked to MNRE, Minister of New and Renewable Energy, they were telling power nahi banega India mein. Because the thing was that mostly people were telling कि India में low enthalpy है. So continuously I was making them call. I have even asked for some meetings there. कि no, we can make a plant. So because of their negative approach, then what I thought, कि let's start a small project. Because when I studied in detail, geothermal power plants are very costly. When we plant for in Tatapani geothermal plant of 3 megawatt, it was costing 100 CR. So India is, we are not having that much of resources and the per unit cost is also very high. Now solar, they are costing 2 rupees 50 paisa per unit. When you talk for the geothermal, it is around 12 to 15 rupees. So I used to tell the policy makers to the ministries, see, when solar started in 2001 or 2002, it was around 20 rupees, 21 rupees per kilowatt. But now, because of the modernization technology and R&D, now it has come down to 2 rupees 50 paisa. Likewise, when we talk about the geothermal, it's a new subject. So it will take some time to get this in. So somehow, but it was difficult to manage because cost is very high. And when you see there are one plant, 660 megawatt plants are there coal-based. So who is going to purchase your 1 megawatt or 100 kilowatt electricity generated from the geothermal? So then my project was there in Telangana, Manuguru. So I met the SSCL GM Exploration and I have given him the presentation. And I told him that GSI is dealing in this area, we are doing the extensive surveys. So why can't you invest small amount, around 1 CR rupees from CSR fund? Because every big company, they are in CSR fund. And the project was inside their coal mining area. And one village was there. So then he was agreeable, this will be one feasibility cap. So let's start 20 kilowatt power plant, it's very minimum amount. Because Bodal was drilled by GSI. Of course, there Bodal was very costly drilled by GSI, but GSI is a mandate to do the work. So they recently agreed. Then they invited us. So our DDG Mughal Sahib is sitting here. He himself, myself, we have went to the Manuguru. We have given them the presentation. Somehow they agreed. And now the work of 20 kilowatt power plant was started in Manuguru. That was a challenge because it was the first of its kind in India. In 1991, Manuguru, this Manikaran geothermal field, 5 kilowatt plant was built by GSI, but unfortunately, due to the landslide, it was been demolished. Since then geothermal division was closed. So at present, since there was no plant, so this Manuguru geothermal field, 20 kilowatt, is the first of its kind in India. And there is a good news that maybe it is almost finalized and July first week or second week, my GM Expo SSCL is sitting here. So he just told me that they are going to invite us for the commissioning and inauguration of that 20 kilowatt geothermal power plant at Manugudu. So after the commissioning of that plant, it's yeah. So this 20 kilowatt geothermal is going to commission by this July, first week or second week. And this will, because when I was talking in many forums, I used to talk for the plants, this, that, people sometimes used to laugh, "Arey, nahi hoga." But I will tell you, this 5 kilowatt plant was already inaugurated by me and Joint Secretary MNRE in 11th November 2022 at Delhi. Because the Shiramisura Industrial Research is commissioning or working on this plant, what they thought, ki let's do R&D, laboratory-based plant. So they make the model like this. And 19th November 2022, we lead the first light of the geothermal energy in Delhi. Now, recently, within 10-15 days, we are going to see the first plants of its kind. It's very cheap. Second, another what I think, then we pursued the Tatapani geothermal field. So Tatapani is, acha, one more thing is that in Manuguru temperature is only 68 degrees centigrade and now at present 62 degrees. Anywhere in the world, you go anywhere in the world at 62 degrees centigrade, nobody has lit the bulb. It's a miracle. And all the technology is made in India technology only. Then you say, why you are selected 62 degree only? When we were having 82 degree of centigrade of hot spring over there. Reason is that fund, money was less. The good prospects were far away from the localities. Then you have to make the grid. After generation of the plant, you have to channelize up to the grid. Then cost was involved. My plan was that at very less cost, let's show the people. So one village was there, Pagedru village, 3-phase line was there, and our borehole was just the 20 meters from that point. So I thought only we have to put the turbine, make the electricity and put it in the 3-phase line. So in that way we chosen. So but that way also it is a miracle because anywhere in India, in world, 62 degrees centigrade power generation is impossible. Now it has been possible. You can see even in India at 62 degree we can lit the bulb. Why not at 80 degree, 100 degree? Tatapani 100 plus degree centigrade temperature we are encountering. So there also what I propose, I just made a meeting. I sometimes used to myself make a call, this thing, that thing, because without synergy, it's not possible to build a plant. So I just called everyone and we had a meeting. Then again they thought, state government don't have money, don't have fund. I then told them, GSI has drilled 3 decades before, GSI along with ONGC drilled 6 boreholes there, all artesian wells. And the temperature is 100 degree plus. Even now when they open the wall, the geyser, I don't have the video right now to show. So 15-meter geyser, water is pressure, you can imagine 50-meter geyser when you open the wall, temperature is 110 degree, 100 plus degrees centigrade. And the depth is only 350 meters. I advise them, why don't you put a small plant here and make it a geotourism? The idea they like very much. Yes. We have a borehole because see, problem, where is the cost involved? When you go for drilling is a costly affair in the geothermal because it's a production well, big well. At present, we don't have the technology. We have to import from foreigners, tender. Each bore, at least when you go for drilling for 2 kilometers, it will cost not less than 15 to 20 CR. So that's why it's very costly. So then I told them, ki when you have a borehole there, you can just make the borehole assembly live, put your turbine and other accessories, and you can generate electricity. Dr. Sarurkar worked in that area. You can ask them, when they worked, that area was a jungle. Now, because of this hot water, now there is an annual fair, there is a big Shiva Mandir and all these things. So, lot of establishments are there and lot of tourists are coming. So, that's why I just advise them, कि we will make a plant with very small budget. We don't have to drill. And based on this plant, what we'll do, we can have the geotourism also. That's why government of Chhattisgarh, that they are talking with the Ministry of Tourism also. And jointly in that way, people will say, yes, पानी से बिजली बनी. तो गर्म पानी से बिजली बनी है देखने के लिए बहुत सारे लोग आएगा. एंड इन दैट वे हमारे 2 टारगेट फुलफिल होंगे, टूरिज्म भी बढ़ेगा और जो पॉलिसी मेकर्स है, जो स्टेक होल्डर्स उनका कॉन्फिडेंस बढ़ेगा. जब हमने मनुगुरु का प्लांट चालू किया तब जाके एमएनआरई ने बोला यस बन सकता है. पहले तो डाउट था, बट जब वह चालू हो गया तो उसके बाद वो पूगा चालू किया. ओएनजीसी भी आया फिर पिक्चर में. तभी ओएनजीसी के साथ ताता पानी में 1 मेगावाट, दैट आई एम ऑल्सो मतलब मॉनिटरिंग दैट प्रोजेक्ट फ्रॉम नागपुर, आई एम सुपरवाइजिंग. तो उसमें काम चालू है. 1 मेगावाट प्लांट वी आर बिल्डिंग एट लेह, पूगा जियोथर्मल सिस्टम. और नाउ विथ ओएनजीसी, विथ अनदर ब्रांच, आई एम इन टॉक विथ देम. So I just told them कि why don't you develop the Tatapani geothermal field? It's very promising and working window is 12 months. In Puga, from earlier time I used to tell them कि Puga there is a problem because working window is only 4 months or 5 months. Within that period you have to do it. But here in Tatapani you have a lot of scope to do. Then another thing is that Oil India Limited, they approached Geological Survey of India for geothermal, development of geothermal. Because I told them, even to ONGC also, कि they are having old wells, oil wells. Those are abandoned wells, they don't got the oil. Those wells are showing the geothermal potential. So I thought, कि why you don't have to drill the holes? Already those wells were drilled for oil. So those wells, especially in Cambay Basin, lot of wells are there having 100 plus degrees centigrade. We can use that energy, we can tap that energy, only we have to put the turbines. So we are in the talk with the ONGC also now, and we will see in future, we may see a good future of geothermal energy in India. But yes, of course, some other scope is also there. Now one question is there, hot springs are limited. Then how it will cater the geothermal needs of the humankind? So here I will tell you, this is only classical geothermal system where there is only hot spring manifestation. But now all over the world there is a R&D is going on for the EGS, enhanced geothermal system. In EGS what happened? You know the Mother Earth is there and granites are mostly India, we are having granites. Above that we are having so many sedimentary, meta-sedimentary sequence, Deccan traps. This granite is a resource of uranium thorium, and because of decay, lot of energy is already preserved, like oil. This energy preserved below the Deccan trap or so many basins. We can tap that energy, natural energy. So here we have to do the 5 to 6 kilometer boreholes. Strata Energy, they have given one presentation in MNRE before Corona. Of course, due to COVID also some 2 or 3 years we have lagging behind. So Strata Energy shows the actual technology, how they are going cheap drilling for 5 to 6 kilometers in hot granite, HDR, hot dry rock. So if that could have been possible, now things are going in this line to have a cheap drilling technology. So with time we'll see. After some time, we will go to tap this energy below the Deccan trap, below Kadapa basin. So many basins we are having where we are having lot of huge energy. So here in future we see when there will not be any coal. If you are depending on the coal, how much time you will depend? 100 years? After 100 years or 200 years, just imagine there will be no coal. Then what? Nuclear, okay. Solar, okay. But with solar, with hydel, it will not cater the need of the humankind. So only Mother Earth will give the solution. Mother Earth is cooling, but the rate of cooling of the Mother Earth and rate of our survival, there is a huge difference. And definitely this Mother Earth, this geothermal energy is going to cater the future needs of the humankind. And one small thing, another I will tell you just within a minute. This space heating is also there. Here in Nagpur, lot of hot summer you can see. If you put geothermal plant, like here in Metro, Nagpur Metro, they have put first of its kind plant. There they use the natural gradient of the earth and they are cooling the all office based on the geothermal energy. Only they have to make some vertical or horizontal geothermal pipes are there and energy converter is there. When only small units and you can do the space cooling. Because आपने देखा होगा when winter you go to the tap or dug wells, water seems hot. When you go in the summer, same well you find it's colder. So only there is when there is seasonal changes, but the temperature inside the earth remains constant. It doesn't have any change of the meteoric temperature condition. So that's based on this. We just use the converter and some technologies there, so we can do the space cooling or space heating. So that is an enormous scope. Even in Nagpur, they have executed it, and I think with time, so many policy makers, even when I am a member of the parliamentary committee in MNRE, so there also I speak, why don't you make it a mandatory for the big malls, big offices to use this technology? Why we are putting the ACs and all these things? Cost will be reduced. So I think MNRE is very serious for doing this space heating and space cooling plant. So in this way, you will see there is a bright future for geothermal. Of course, it's a late runner, but in a long run, it's a marathon run. Long run, only geothermal will be there. After 200 years, after 500 years, only geothermal is going to survive. Others will be there, because at that time, there will be no coal. Then what? From where you will? Of course, hydrogen energy is also coming up, but geothermal also will be one of the good energy in future. So that's all. I'm not taking much time. Thank you very much.
Thank you very much, Dr. Vishalji. I don't think there is time for any questions. If anybody has any queries, questions, clarifications from him, please ask him during lunch time. But there is a request from Brigadier Sunil. He wants to speak for 2 minutes about Demchok hot spring. But I invite Brigadier Sunil, but please restrict your talk to 2 minutes you have asked. I am giving you 2 minutes, but then please.
I won't take more than that. Jai Hind to all of you. I am an army officer. I stay in Nagpur only. My name is Brigadier Sunil Gopanda, and I was posted there. I was looking after the Demchok area and couple of other areas right up to the Galwan Valley, which was in the news last year as well. There's a lot of technical topics are going on. I read it in the newspaper. That's why I came with the advice of Mr. Chauhan. Demchok is right onto the border. I will give a little bit of just half a minute's perspective, because a lot of technicalities going on. Certain military aspects should also be known by the audience. This particular point, Demchok, it is on such a border, it's very difficult to define whether it belongs to us or it belongs to China. It is right onto the border. Even it was difficult. I was the chief construction engineers, high altitude areas, northern borders. I was looking after that. And we are posted in a very, very remote areas. So therefore, we need certain kind of a renewable source, which is one of the future power of India. In that is the geothermal energy is one of that. So this particular point, which is a jharna type of thing, we tried to explore that thing with our own knowledge. Of course, that much we don't have that much of know-how of the GSI. But then one of the Delhi company gave us the support. They were also retired army officers. They did their concoction, entraption, and we tried to take that particular energy. One day it so happened we started to doing that thing. The 2 soldiers of the Chinese came and they hit our soldiers. बंदूक लेकर आए, उन्होंने हमारे सोल्जर को मारा. And Manekam is with the, but we don't use the rifle. Till that time we never used to use, because as per the Government of India Act. क्या करना चाहिए? Then after we constructed, as you were mentioning, we have constructed the hut. You must have visited that, I don't know. That particular hut design, everything I did, and it is made with the help of the POF metal. We covered that point. That particular point which is emerging from the ground, that has been covered with the polyurethane foam hut. And in that hut, we took that particular point pieces. कि वो हमारा होना चाहिए. Because in the entire China, for the general knowledge of the everybody, 3,488 is the length of the northern border from one end to up to the Arunachal. That is the Chinese border of government of the India. Whether it is fully us or theirs, it's still a perception point of thing. That a third round has taken place recently. And that's how it is right now with us. and that particular aspect we are trying to do. There, of course, I finished my job, I am posted out, I settled in Nagpur only, here Pratapnagar. I keep reading, so I just read it that I will gain additional knowledge and good speakers out here. It's one of the very interesting session out here. I didn't have much of a time, but I requested that I can come, and it's so nice. A lot of people have come well prepared. I have also given large number of presentations on this thing, but they were purely from the military and technical point of view. So I think I will share with all of you in just 2 minutes, sir. Thank you.
1 minute is already over.
Correct, Bilkul. Thank you very much for this thing. Okay, now I finished my SOP. Thank you very much to all of you. Thank you. I have completed. No? That's, I said I'll just not take more than, I got a lot of things to tell about that thing, but I know the importance of the particular session. No, I'm not asking. I just finished that thing. Thank you very much, all of you.
Thank you, sir, for seconding what I told. 381st hot spring studied by GSI is Demchok hot spring, and you just told them how difficult to approach to that place and the study the hot spring. So that's why our Geothermal Atlas we included hot spring. Very special, sir. First time it has been studied, because Chinese, they never allowed any Indians to approach that place and study, even go at that point. But somehow with the help of military, we just visited, collected the sample, even published an international paper also on the Demchok hot spring. So in that way, very tough, but our team of experts from GSI is very committed, and with lot of difficulties, we approached that plane and collected the samples. Thank you.
Okay. I now invite Dr. Alpa Sridhar. Hello. Dr. Alpa Sridhar, please. Please present your paper. Just 10 minutes time given. So you may start, please.
Yeah. So, good afternoon, and I'll take you back to discussing the river response to climate change. I'll be talking about some of my observations on how the paleohydrological proxies from alluvial regions can be used to infer the summer monsoon variability, and also whether these paleohydrological proxies actually respond to the monsoon variabilities. So this is how I actually planned my study, and there are a number of paleohydrological proxies which can be analyzed to understand the change in the hydrological regime, especially in river basins. So yeah. Primarily, I focused on the geomorphic evidence which can take place or observed as the planform changes and paleochannels in any river basin. Then the sedimentary evidence actually comprises of the terrace sediments, and because I am actually focusing only on the later part of the Holocene, we have many terraces in the alluvial plains of Gujarat. And another proxy which I bank upon are the slackwater sediments. Another proxies would also comprise the geochemical and the biological evidence from the sediments, basically. So what I want to discuss here is the spatial and temporal correlation among the paleohydrological proxies, monsoon variations link with the proxy data, and also try to compare the monsoon variations and the modern flood data. So, yeah, I won't go into the details of this because I think Professor Chamyal has already talked upon the importance and significance of the rivers in the semi-arid region of Western India and how sensitive they are to climate change.
Okay, again, this just to show you the climate zones and the major rivers that have been studied. Don't want to go into the details because it has already been talked about. So I just come to a few examples of how geomorphic proxies can help in determining the hydrological changes that have taken in the past. So this is one of the examples. This is a shady river where we see the indications of paleo channels, and if you see the present day channel is a very narrow channel running through actually a very large broad paleo channel. These rivers are actually also called as the misfit rivers. And when we try to, analyze based on the geometry of these channels and use the estimates which can be done using some paleohydrological equations which are already available. I don't go into the details of this of the equations because of the time limitation, but what I want to show here is that based on the geometry of the paleo channels, the meander radius or the width of the channel, we can actually quantify to a certain extent the paleo discharge of the rivers. Another example is from a very large meander from Narmada, where you can see the meander radius or the radius of curvature for a paleo meander versus the radius of curvature for the present meander. And as it is evident, definitely the paleo river or the paleo channel was much larger and it flew a larger discharge. Similarly, this is an example from the Mahi river where actually I had used the geomorphic proxy of point bar data, and it is now established that the point bar dimensions and the geometry of the point bars can actually be used to estimate the channel discharge and the dimensions of the channel which actually deposited the paleo bars. Okay, then coming to the sedimentary proxies, as I said, sedimentary proxies I studied in two parts. One was the slack water sediments and another was the terrace sediments. So just to give you an idea about the slack water sediments, if you are not aware, basically slack water sediments are related to the paleo floods. So whatever floods that took place in the past, and these records go back so far as the rivers in semi-arid alluvial plains are concerned, they go back to about 5,000 years before present. And the floods that occurred during these 5,000 years have been somewhere, in some basins, in some regions, recorded in the slack water sediments. And these slack water sediments in this region are seen in the ravines. Okay, because as Professor Chamyal had mentioned, the rivers in semi-arid Western India are highly incised, and these incisions have provided accommodation space for this slack water deposits. So based on the slack water deposits in this is an example from the Mahi river, and if you can see the data goes back to about 4.6, and this is an example from the Sabarmati river. As I said, and this is an example how based on a slack water deposit data, you can actually infer the paleo flood stage at a given particular time, because we do have numbers on the sediments, and if we have the number on the sediments, then we can estimate the paleo flood stage and thereby the paleo discharge of that particular time. Okay, so then coming to the terrace sediments. So similarly, terrace sediments also provide some indication on the change in the hydrological conditions of a river system. As we know, coarser fractions relate to higher energy, finer fractions relate to lower energy. I won't go into the detail of that. But what we see is that in a section like this which is shown here, we have a huge thickness of sediments where we have alterations of fine sand and clay, fine sand and silt sediments, which actually represent a slack water deposit record. And this is again from the Narmada River. Similarly, this is another section in the Narmada River where also we find these slack water deposits. And an interesting thing that came out of this study was also that the site is located on a tributary basin. And what we found was that the deposits in this tributary basins actually belonged to, for a considerable period of time, they came from the Narmada flood. So during the back flooding within the tributary, the sediments were deposited, and they were then overlain by the sediments from the tributary, that is the Karjan River. So based on these studies also, we can have an idea about the hydrological conditions of. Okay, so to correlate the data, because usually we say that fluvial data is not complete. So just to support, we also tried to understand the flood record from the lacustrine archives, and this is just one of the examples where we do find correlation. We find one of the flood events which can be correlated to the one that we found in the Mahi River basin. So that was around 42, that is 4,000 to 4,500 time period. Okay, so coming to the biological and geochemical proxies. The biological proxies we have been using for just getting an idea about the deposition conditions, the environment during the deposition of sediments, and a lot of this work has been done in collaboration with the scientists from BSIP. And the geochemical data has been largely used to understand the contribution of the tributaries. So the flooding pattern in the mainstream and the tributary. So what were the phases where the mainstream was actually flooded, and what were the time periods when the tributary basin was contributing to the sediments. That has been actually identified using especially the strontium neodymium isotopes and the other elemental studies. Okay, so these are the numbers which largely from these river basins that we could get, and this show that we have periods of enhanced monsoon, we have periods of weak monsoon. Against that we have the high magnitude flood events. Now if we have to see how these correlate, so here if we can see the green dots, they show the enhanced monsoon period, and the red dots are the weak monsoon periods, with the blue which are the high magnitude flood events. And if we can see here, the high magnitude floods actually cluster at places where you have weak monsoon conditions. So, or in other words, there is a clustering of flood events where we have a transition in the climatic condition from humid to arid or arid to humid. That is the time period when we have the clustering of flood events. So this also shows the same thing, that at different time periods we have had peaks in the paleo floods, and they show clustering at certain time periods where the climate was in a transition phase. So what we need to understand here, that actually what does it take to cause a high magnitude flood? Is it only the precipitation which will lead to a high magnitude flood? The answer actually is no, because a threefold rise in widespread extreme rain events over central India is noted. We have exceedingly high data to say that precipitation will increase in the climatic warming or global warming scenario, but we still do not have any evidence for widespread increase in the flood occurrence. And that is the reason, because not necessarily wherever we have a high or enhanced monsoon condition, we do have high magnitude flood events. So this is just to give you an idea about the present day conditions. I have, a record from about, for about 100 years odd. And if you can see here, the green line is for the Narmada, the precipitation, red is for the Mahi, and blue is for the Sabarmati, and this, the dots and the triangles are the high magnitude floods that have been recorded. This is the gauge data. So if you see here, the modern, in the last 100 years also, we do find that we have these floods, corresponding to wherever we have a low in the rainfall pattern. So they are not actually corresponding to where we have a peak in the rainfall pattern. And therefore, these floods in the three river basins are not synchronous in that way, but only when we have the floods in a peak monsoon, all the three basins show the presence of floods. So this is how, that each basin actually has a different response to the change in the rainfall pattern. So this is just a summary diagram to show that within the alluvial plains of Western India during the late Holocene, there have been climatic changes, but the flood events have not responded per se, that we cannot have a one-to-one correlation between enhanced monsoon and high magnitude flood events. That's it. Thank you so much. Yes, sir.
Some one or two quick questions.
Thank you.
Please give him mic.
You have mentioned about the biological proxies and your work with DSIP in Lucknow. So, is it the diatoms and something else? What are the proxies?
No. So far, we have been able to, because to tell you the truth, being a semi-arid region, the sediments here are poor in, pelinoforms. So we do not get a very good record, but what we have done, we have tried to understand the organic matter. So with the different types of organic matters which are being available and analyzed, and on basis of that we have just tried to interpret whether during that particular time period what was the water availability condition in that region. That is the thing that we have tried to understand.
Okay, thank you.
Yes, Dr. Rajiv.
Yes, sir.
Flood will come.
No, sir. Actually, that is a point. It is not without precipitation. See, floods, what I am talking about are the high magnitude floods. Okay, so there are two things. We have high magnitude, low frequency floods. We have low frequency, high magnitude floods. So high magnitude floods are those which occur rarely. Okay, otherwise every monsoon a river will get flooded, every monsoon there will be deposit on the floodplain. But we are not talking about that. That is one thing. Another thing is that when I say weak monsoon doesn't mean there is no precipitation. And if during a weak monsoon we have a flood, it is invariably related to a flash discharge of, so that something like a torrential rain within a not a very enhanced monsoon. So it's not a question of no rain. Rain is there, but how the precipitation is occurring. In an enhanced monsoon, I believe over a larger time period you have a stable rainfall. Whereas when you have a weaker monsoon phase, it is erratic. And those are the conditions where there are more chances of flooding.
Or this is change into the river bed. If precipitation is there, so the size of the river channel became small. Small rainfall will flood.
No, sir, but the channel, the dimensions don't respond to the change in discharge so fast, because it takes several years for that channel form to change. It doesn't change that fast.
Basically, it is a
That is why I showed in the first slide where we have a huge paleo channel within which we have a present day narrow channel. But that paleo channel still remains. So there is no, it doesn't change that fast.
Okay, thank you very much, Dr. Alpa, for the nice presentation. Thanks a lot. May I now invite the next speaker, Dr. Milan Erlekar. I don't know. 10 minutes, please.
Respected chairperson on the dais, Professor Chaman, Professor Kale sir, and respected Dr. Sakre sir. Okay, sorry. I thank the organization to giving me the opportunity to present my topic from the grain size analysis and the characterization of depositional sedimentary environment of the Holocene sediments from the Vijaydur Creek to Devgarh Creek. Okay. Now the coastal environments are very dynamic environment. That is mostly in their topography, then the climatic phases and the vegetation. The textural characteristics of very diverse geomorphological units of nearshore sediments. They are characterized by the parameter, mostly from the geomorphological unit like the sea cliff, wave cut platform, tombolo, sandbar, sandspit, etc. And the sedimentary, like the primarily sedimentary, that is the environment, influenced by a number of erosional as well as the depositional features. Now the foreshore zone, we are collecting from the sediment sample from foreshore zone, backshore zone, raised beach and beach dune sample. Now the foreshore zone sediments are characterized by mostly impacted by the waves action continuously and the mostly adapted by the beach morphology in the form of beach face slope and the shoreline orientation. Now this is some cartoon picture. From here it is mostly now the backshore sediments are mostly characterized by impacted by the wind as well as the mostly from the slope, and this the impacted by the that is the shoreline changes from the raised beach as well as the beach dunes. Now the grain size or the characteristics of the different sub-environments of the beach can be quite distinct. It is very short time, I will explain in a very... Now this is the area, this is mostly from the Vijaydur Creek from here. These are the carrying from the sediment sample from these are the Wagoton River and deposit into the Arabian Sea. Then it is the northern part, then the southern part is the Kharda River basin. The Kharda River sediments are carrying from here and the Devgarh Bay. Now this is mostly, that is a very good interesting feature from here. It is mostly the Padel stream. Earlier the Padel stream flowing from the east to west and directly meet to the Arabian Sea. But actually it is mostly in these features, that is the Wagoton fault. The streams originated from the east to west, and here in this Kurli region, they are suddenly flowing towards on the north direction and meet to the Wagoton River. Now here reported from the Rajamanikam and Gujar in 1984, two offshore faults, that is here in this region. Now this is mostly from the Vijaydur port, and here from the Vijaydur to the mostly from these, all these are the northern sector from the mostly that is found from the pocket beaches. Now the Konkan region experiences a humid tropical climate throughout on the year with the average rainfall of about 2,500 to 3,000 millimeter. Then mostly followed by June to September. During the monsoon season, the wave exceeds more than that is 5 meter in height. A wave period of 3 to 6 in tidal. They are taken by the Karlekar and this paper. The study area is divided into two sectors based on the coastal geomorphological features. The northern sector, mostly from the erosional in nature, mostly from wave cut platform, as well as the headland, promontories, as well mostly from the sea cliff, etc. And the southern part of the area, that is the depositional in nature. Now this is the mostly from the area from the Vijayadurga Bay. This is mostly the headlands, the mostly made up by the Deccan Trap at the bottom and the overlain by the lateritic portion from here. This is the Devgarh beach, that is the pocket type of the beach are found here. Now these are the central part of the area. It is very important from the gire, from the headland, they are eroded. Now this the drainage map of the study area. The mostly that is the drainage type are the rectangular in nature. Now this is we are collecting from the sediment sample total from the north to south, that is the 24 locations. Now these are the some methodology. Samples were collected from the foreshore, backshore, raised beach and beach dune samples. After that we are taken from the total 164 sediment samples, 82 for each season like the pre-monsoon and 82 from post-monsoon. Now we are taken from the collected sediment sample from these regions. From here I will show you the acrylic pipe in 1 meter. We are inserting on the subsurface in the 50 centimeter to 70 centimeter. Then all these are the foreshore zone. From then the backshore zone, these are the raised beach and the beach dune. The beach dune height of about 14 meter to 20 meter. These are the longshore current transport deposit. It is the development from very well development from the sand spit. Then it is a very good inclination from the lamina, from the dark black color, it is found in the heavy minerals mostly. Then here also it is a very important for alternate layers of the dark and black from the 2 mm to the 15 mm. This is mostly from the region, from central part, it start from southern sector. It is a very well development from the Tombolo. This is mostly from the sediment from quaternary, late quaternary. This is a very interesting feature from all these are the beach, from these the boulders, that is lateritic boulders actually, mostly they're carrying on the topple down on in this hillside. Now this we are collecting from the sediment sample this is actually the Vijayadurga Bay. Now this is the 1, 2, 3 sample from the Vijayadurga Bay, then it is the Gharkar Wadi sample, then it is the Kol Wadi and then the Gire sample from here. According to that, from the mean size standard deviation skewness value, the mean size value ranges from these are the graphic measure from the grain size analysis from the foreshore zone, the pre-monsoon sector, the northern sector. The mean size value ranges between the 2.03 to 2.61. Therefore, it is a fine grain. It is a 100% fine grain. It is found on the pre-monsoon in northern sector. The standard deviation value ranges between 0.34 to 0.895. Therefore, it is a very well sorted to moderately sorted. The skewness value ranges between 0.42 to minus 0.25. Therefore, it is a strongly fine skewed to coarse skewed in nature of the sediments. The kurtosis value ranges between 0.79 to 2.10. It is a platycritic to very lepoticritic in nature of the sediments. Then the southern sector, that is the foreshore zone in the southern sector, it is the changes from the mean size. It is the 1.94 to 2.62, that is the fine grain to medium grain. The standard deviation value ranges between the 0.405 to 0.665. It is a well sorted to moderately well sorted. The skewness value ranges between 0.31 to minus 0.39. It is strongly fine skewed to strongly coarse skewed in nature of the sediments. The kurtosis value ranges between 0.43 to 1.81. It is a very platycritic to very lepoticritic in nature of the sediments. Then it is come to the southern sector of this area. It is start from this is mostly from this earlier one. The streams are directly meet to the Pural Kotar region. This is the paleo channels. In this Pural Kotar region, we are collecting from the sediment sample, like this is mostly from this one, that is in this region. Then this is the backshore zone region, that is the pre-monsoon in the northern sector. The value ranges between the mean size 1.68 to 2.99. It is the changes from fine grain to medium grain. Then the standard deviation values ranges between 0.41 to 1.01. Therefore, it is a well sorted to poorly sorted in grain size. Then the skewness value ranges between 0.31 to minus 0.31. It is a strongly fine skew to strongly coarse skewed in nature. The next one, that is the backshore zone in southern sector. What will happen? In the southern sector, in all these are the mean size, it is a fine grain, it is 100%. The standard deviation value ranges between 0.31 to 0.82. It is very well sorted to moderately sorted in nature. Likewise, the raised beach sediment sample, we are collecting from the Vijayadurga, then the Kolwadi and the Gharkarwadi sample. These are the mainly fine grain to medium grain. The standard deviation value ranges between 0.34 to 0.75. Therefore, it is a very well sorted to moderately sorted in nature of the segment. The skewness value ranges between 0.06 to minus 0.59. It is a fine skewed to strongly coarse skewed in nature. Then the raised beach from the southern sector, it will be happen actually the mostly all these are the mean size ranges between 2.14 to 2.51. It is 100% fine grain are found in the raised beach in the pre-monsoon sector in the southern region. Then the standard deviation value, it is ranges between 0.28 to 0.57. Therefore, it is a very well sorted to moderately well sorted in nature of the sediments. Then the kurtosis value ranges between 0.85 to 1.98. This is the platycotic to very lepoticotic in nature. Last one, the beach dune sediment sample from pre-monsoon in northern sector. Here it is found from the 100% in the fine grain sediment. Then the standard deviation value from 0.39 to 0.56. It is a very well sorted to moderately well sorted. Then it is the skewness. It is the ranges between 0.63 to minus 0.29. The strongly fine skewed to the coarse skewed in nature of the sediments. The kurtosis value ranges between 0.84 to 2.0. That is a platycotic to very lepoticotic in nature of the sediment site. Then during by the southern sector of the pre-dune sample, these are the whole, that is the fine grain sample are present. The standard deviation value 0.18 to 0.5. It is a well sorted to moderately well sorted in nature of the grains. And that is the, come to the point from the post-monsoon season in northern sector from the foreshore, it is the changes from the scenario from here. It is the mean size. It is whole from the mean size value. It is a coarse grain, that is 100%. The standard deviation value ranges between 0.89 to 1.81. That is the moderately sorted to poorly sorted nature of the sediments. The skewness value, it is the 0.14 to minus 0.35. It is the fine skewed to strongly coarse skewed in nature. The kurtosis value ranges between 0.84 to 2.47. It is a platycotic to very lepoticotic in nature. Then the southern sector also same. That is the mostly all these are the fine grain. In the mean size grain, it changes to coarse grain nearly from the 100%. The standard deviation value from 0.65 to 1.87. It is the moderately sorted to poorly sorted. Last one. All these are the backshore. From the foreshore zone, it will be the changes from this region. Same from the raised beach, then the beach dune of the sediment sample. Now, all these are the sector from the mean size standard deviation. The post-monsoon, it will be the changes. Then the bivariation plot from simply, that is the mainly from the graphic standard deviation versus graphic skewness. It is all the sediment sample are fall down mostly on the beach environment from the pre-monsoon season from here. The few very sample, that is the carrying from the Wagotan River and the Karda River, that are adapted from the foreshore and backshore. Then the mostly from same, it is the Rajamanikam. Most of the sediment sample are fall down on the beach environment. Then the Moila and Weather, that is these are also same sample are falling on the beach environment. Then these also, that is the majority of the samples are falling on the beach environment. Then the bivariate plots from the post-monsoon season here. In this region, the dominance of the river samples are there because the rivers are carrying from in the time of the monsoon from three rivers. The one is the north in Wagotan River, in the Panse River and the Karda River. They are carried from the sediment sample from the river and environment. Now the linear discriminant analysis studied by Sahu, the mostly, okay. Now the heavy mineral analysis, that is the total from the 184, that is the sediment sample that were prepared from the heavy mineral analysis. In all these are the region from the black, these are the mostly from the OPEX. And these OPEX are all these are the mostly the carried out from the ilmenite as well as the magnetite region. The concentration of the heavy mineral in the foreshore zone and the backshore zone and the raised beach varies are there. In the most of the in foreshore zone region, that is the heavy mineral concentration is larger, and therefore that is the mostly from the apathetic by the table from here. It is the OPEX are found from the very high. That is the mostly that is the 59 to 74%. That is the in the region from. This is the OPEX, that is the sample number 1 is Vijayadurga, Kolwadi, then the Gharkarwadi and the Pansewadi. All these are the mostly from these the OPEX are found. Then other is zircon, tourmaline, rutile, garnet, epitode, kyanite are also found. Last one, the conclusion.
It's all right. I think you have done.
Thank you.
Conveyed the message what you wanted to convey. Any question? Yeah, Dr. Rajinigam.
Okay, sir. Yeah.
Do you have any evidence that river which is joining toward the right-hand side of the Vijayadurga Fort, sometime back it was joining towards left-hand side?
Actually, the NIO people earlier worker, that is the mostly the Vijayadurga earlier it was on the island fort. That is the...
Yeah, two reasons I will tell you. First thing, there is a submerged wall.
Submerged wall, yes.
Okay, it's a very good archaeological work.
Yes.
Nobody has done it in detail. Okay, so, and that river, which is right now joining right-hand side, we did a shallow seismic survey.
Yes.
We found a paleo channel towards left side.
Yes.
It means river was joining probably left-hand side. So
Yes.
whether it is the tectonic activity which has played a role, or it is the sea level changes which brought this wall down into the sea. Sometime if you get a time, you can do that research. Thank you.
Okay.
Helikaji, I just want one clarification. Of doing this textural analysis,
Yes, sir.
what was the purpose? What was the aim of detailed textural analysis? Objective of this?
Objective of this is the most from the provenance of the sediment sample, and the second one, the heavy mineral analysis, that is the region.
Texture won't give you provenance, no. My just quest है, आप सही होंगे. You collect sample from foreshore, you collect sample from backshore, you collect sample from river channel. They are going to tell you the characteristics of those geomorphic zones only. No? Okay. So if the purpose is to know about a sediment whose geomorphic expression is not clear, and you want to know whether this particular feature is a product of foreshore or backshore or river, then this textural analysis will help. Yeah. Or the other purpose could be to characterize the foreshore, backshore or river sediments in that particular area and standardize this.
Yes.
That could be another purpose of it. You please just think over what I have said. Maybe, yeah.
Thank you, sir.
I just would like to add, see, what you have done is basically data generation. Okay? Now this stage has passed.
Yeah.
In science, this stage has passed.
Yeah.
You should be able to, say something about the process, something more than that. It's not just the data generation.
Exactly.
So data generation, that stage has passed long back, 20, 30 years ago. Okay. Now you should do something more than this.
Thank you.
How you can interpret the processes. So.
Okay. Thank you, sir.
Thank you. Okay, then. Thank you, Dr.
Thank you.
Thank you very much.
Thank you, sir.
So now, may I invite the next speaker is, who is the one? Okay, Samreen Firdaus Chaudhary to present her talk
on assessing the impact of accelerated concentration of heavy metals from soil subtropical climate around Godavari Lake, Maharashtra. Please go ahead. Just 10 minutes, please try to complete.
Good afternoon, everybody. Myself, I am Samreen Firdaus Chaudhary. I'm doing my master's from Department of Geology, and I'm here to present or give a talk about assessing the impact of accelerated concentration of heavy metals from the soil of tropical climate around Godavari Lake, Maharashtra. So, first of all, what is pedogenesis? So pedogenesis is nothing but a term used for the soil formation, and as we all know, soil is a vital and very important part of an ecosystem. So what are the processes that leads to the soil formation? The processes, the 5 major factors that come into role is the climate, the organisms, the relief, and temperature, and time. So in short, we can actually conclude, or we can summarize that soil is nothing but the disintegration and transportation and deposition of a rock into its of a parent rock into its simpler form. So soil has multiple factors, right from supplying water, fundamental resources like water, oxygen, which is primary production. So the study location was Godavari Lake, which is situated near Nagpur Tehsil. It is 6 kilometers away from the Nagpur Tehsil and 97 kilometers away from Nagpur. So the Godavari Lake has sandstone present in it, which is of the age Neoproterozoic, and it also has laterites of recent to sub-recent ages. The Chandrapur district has physiological region. It is divided into 2 main regions: the plain regions and the hilly regions, and the rivers that flow around it are Vainganga, and as we all know, the soil around a valley is always fertile. This is the land use pattern of the area. As we all can see, most of the part of this area is covered by forest, and the blue shows the area of the lake. The red depicts the settlements over there, which is quite less. The methods that were used were graph sampling, profile sampling, X-ray fluorescence, and loss on ignition. Loss on ignition was done to study the organic and carbon content in the sediment, and X-ray fluorescence for chemical analysis. Soil profile, just to understand as to what we get, at what depth, what we are getting in the soil profile. So these are the locations, latitude and longitude given for us to understand from where we took which sample. So the first profile, as we all can see, it has the first, that is the A horizon has light brown, the A horizon has light brown color, then followed by brown and dark gray. And for the TC, that is total carbon, we can see the carbon content, the total carbon content for both the bottom and the top soil, it's more compared to the IC, which is inorganic carbon, and TOC, which is the total organic carbon. For the second profile, for the second area, for the ground profile, second soil profile around the Godavari Lake was, it showed, the first layer shows light brown color with fine to medium grain sandy clay, then followed by light brown, fine to medium grain silty clay, then brown, fine to medium grain sandy silty clay with large pebble fibers, and the last dark brown coarse to medium grain silty sand clay with pebbles and rock fragments. Here too we can see the total carbon content for both the bottom and the top soil is more, but the total organic carbon, it increased for the bottom, while there is a declination towards for the top soil. The third profile, it shows light brown color at the top with fine to medium grain sandy clay, then light brown fine to medium grain silty clay, and dark brown color coarse to medium grain sandy grains. Here also we can see that the TC, the total carbon, is quite high compared to that of the inorganic carbon and the TOC. It shows a declination pattern. This is the fourth profile. We took 5 profiles, and this is the fourth profile, fourth soil profile. It shows light brown color, reddish brown color, then dark brown color, and reddish brown coarse to medium grain. Here the bottom soil shows a high percentage of TC. After that, there's a sudden drop for the inorganic carbon, but the total organic carbon shows there's a rise for the total organic carbon compared to the bottom. And the fifth profile, for the fifth profile, the first layer was light brown in color, then brown, then dark brown in color. Here also the total carbon compound, the total carbon percentage was high compared to that of the total organic compound and the inorganic carbon for total organic carbon and inorganic carbon. So we'll compare all of these. We can see the TC is quite high for all of them. The TC is more. So what does this tell us? The TC is fluctuating, and it shows that the TC is fluctuating, and the carbonate content of the lake was varying with the fluctuation concentration from different direction in the watershed. So at different time, different organic matter came into that catchment, which was from in and around the Godazari lake itself. Means there was no anthropogenic activity or influence of something else. For heavy metals, and we can see barium is more for every profile, followed by increased in rate of vanadium, zircon, rubidium. The same goes for like 4th and 5th ground samples, soil profile. So this is a dendrogram which actually shows the the correlation between the minerals. So here for the first, that is the A, as we can see, Ki comes from the same family. PAC, that is PCATI, Mn, Fe comes from the same family. Mg, Al, and Na, they are coming from the same source. As for the B, we can see that Cr, zircon, Ba, Nb, they are coming from the same family, same source. Co, Ni are coming from the same source. Cu, Zn, and Ga are coming from the same source. Pb, Th coming from same source. VSC coming from same source, and Cr, Rb, and Sr, they are coming from the same source. So here we can see that there is a increased rate in the K, and followed by this profile. The readings show that Mn is increasing. It shows that Al and Fe were there, and Si was quite high in that area. So this is correlation coefficient, which shows negative and positive correlation between elements. The Na shows For Na, there is a positive correlation of Si and K, while there is a negative correlation for manganese. Same goes for magnesium, then aluminium, silicon, phosphorus, calcium, titanium, manganese, iron. The summary, industrialization and urbanization along with population growth and agricultural activities had led to the increase of contamination. But in this area, the contamination was not done by any anthropogenic activities. It was coming from the catchment area itself. The heavy concentration of BaCr, vanadium and zircon shows that this soil is phytotoxic, and if the rate or if the concentration of these elements keep on increasing, it will be harmful in the longer run. So further studies are needed for this area itself, because we didn't generate that much data to solidly prove our point. So with this, I would like to conclude my presentation. I would like to thank Dr. Samaya Humne, Dr. Sumedh Humne, Sonam ma'am, and Ishika, who helped me out in this presentation. Thank you.
Thank you, Samrin. Very well presented, and I really appreciate being a student. You were very confident.
Thank you, sir.
So, any quick questions? Any question to Samrin? Just appreciate her. She is young.
Thank you, thank you.
So, thank you very much. So, I think with this, this session almost is over now. I don't think any more presentations are left. So, I really thank all the speakers for keeping time, and my colleagues, if they have anything to add to it. Otherwise, I will conclude by saying that we are really thankful to the organizers for giving all three of us this opportunity to chair this session. So thank you all very much. Okay.
Persons. I like to request Dr. A.K. Chatterjee sir to felicitate our chairperson, Professor L.S. Chamial sir. Sandeep Roy. Again, sir, just a minute. I would like to request Chatterjee sir to felicitate Professor Vishwas Kade sir. I would like to request Chatterjee sir to felicitate Shri Vishal Sakre sir.